have this symmetry discussion. I don't think you talked about these rules in Algebra 1 or geometry, so this should be new to Algebra 2. We basically have to tell whether our function is even or odd. And you can do it both algebraically and graphically. I think graphically is easier, but sometimes it specifically says show it algebraically, so we're going to go over both. So to test graphically, a function is even if it is symmetric to the y-axis. Okay. So if you take a look at this first example and you kind of find your y-axis, you kind of picture like in kindergarten folding that sheet of paper and making a heart on half the side, and you open up, it's symmetric. It should look the same on both sides. That's what we're saying when we're saying symmetric to the y-axis. So this is an even function. If I look at the picture to the right, again, I'll find the y-axis, and it should look the same on both the left and the right. Again, even function. Okay, so again, it's just something you're going to have to memorize. Even is symmetric to the y-axis. All right, odd. A function is odd. All right, and as you're highlighting here, I want you to really emphasize this O. A function is odd if it's symmetric to the origin. And again, the reason I'm emphasizing that is they both start with O, so it's kind of easy to remember. An odd function is symmetric to the origin. Now, that one's a little tougher to think of. You definitely hit the word idea of origin in geometry. How would you describe something that's symmetric to the origin? Does anyone have like a memory of this? Or a trick they used? Crickets. Nothing, no one remembers? All right, so one thing, it has to pass, if it's odd, it has to pass through the origin. That's one quality that it has to do. All right, so what I used to do, I don't know, when I was in high school taking geometry, to tell if something was odd, literally I want you to take your book and flip it 180 degrees, flip it upside down. So everybody rotate your book. Okay. If it's odd, looking at that picture, so it's probably on the right-hand side now, it should look the exact same. Does it look the exact same as mine facing the right way? Okay, that is what makes it symmetric to the origin. If it's a rotation. If I rotate it 180 degrees, it should look the exact same. Okay, so when you're taking this test and you see an odd question, you should be flipping your test over to see if it looks the exact same. Taking a look at this example, so I'm going to put a dot, I guess, at the origin. I'm reflecting over this, or rotating around this point. So maybe let's put a rotation of 180 degrees. Flip upside down. All right, so again, just for practice, if I'm thinking this is odd, you'd be flipping your paper 180 degrees. So go ahead and flip your book one more time. Take a look, is the hump on the right above the hump on the left below? Okay, make sure it matches, because sometimes they're close, sometimes parts of them are correct. We want to make sure that's what we're rotating on. Notice neither of my answers was x-axis. Let me just review why I can't be a reflection over the x-axis. What is wrong if I try to reflect over the x-axis here? It's not even a function, that's right. It's not a function. So your answer is never going to be x-axis. Just keep that in mind in the multiple choice. Even is y-axis, odd is origin. All right, so the test for graphically that's pretty much it. Even is y-axis, odd is origin. All right, test algebraically. Now again, these are the rules we got to memorize. A function is even if f of negative x equals f of x. Okay, so what the heck does that mean? So I'm going to say even. This is the rule you're going to write down. F of negative x equals f of x. And what that means is it's the same as the original function. F of the function is odd if, when I plug in negative x, f of negative x, I get negative f of x. So it's odd. If I substitute a negative x and get negative f of x, notice it has the opposite sign of the original function. It didn't come out with the original, it came out with the opposite of the original. Okay? It's neither, if neither one of these answers, then the function is neither even or odd. All right, so let's kind of put this all together. Different ways we're going to see this asked. Consider the graph of the function, sketch the other half. All right, so if they tell you the function is even, what is your brain saying you're symmetric to? Y-axis. So I want you to finish the picture where you're symmetric to the y-axis. If you fold in half on the y, draw a line right down the center there, draw the other half of the graph in. See if your neighbor likes your picture after. You want to be symmetric to the y. So I think it should look like this. If I fold right, and I'm going to highlight that y-axis again, right on that y-axis I should be able to fold, and it should land right on top of each other. Let's talk about what the points changed. If I was at 3, 5, what did my point become on the reflection over the y? Negative 3, 5. Does that make sense? Reflect over the y-axis, make the x negative. So this could become negative 7, negative 2, and obviously 0, 0 is going to stay the same. All right, let's think about origin and try to come up with a rule. So odd, O word, I'm thinking I'm a reflection over a rotation around the origin. So odd, I want origin. So remember, that means if I flip this upside down, it should look the exact same. So if I flip mine upside down, what quadrant should my other half be in if this is 1, 2, 3, 4? Well, I landed in quadrant 3. So I know that my origin's got to come this way, right? Okay, so if this is the point, 0, 0 is not going to change, of course. If I have the point 3, 5, and I know I'm coming this way, what part changed? I know I had to end up in this quadrant. What happens to the x value? And what happens to the y value? Negative. Notice again, odd, origin, take the opposite signs. Another O word. So 3, 5 is going to become negative 3, negative 5. What should 7, negative 2 become? Negative 7, positive 2. Opposite signs. 1, 2, 3, 4, 5, 6, 7. Negative 7, positive 2. And we'll connect. Okay, so when you hear O, you got to think these 3 O words. Odd, origin, opposite signs. All right, keep going. Describe the symmetry of an even function. So again, just reiterated the same thing. Even should be symmetric to the y-axis. Odd, there's the O word, odd, is symmetric to the origin. And again, I want to think opposite signs. All right, so same type of question, just asked in a table versus a graph. So it says, complete the partially filled out table. All right, so they're telling us we're even. Okay, so again, your brain is saying even is symmetric to the y-axis. All right, so think about this, and you can always even plot a point for yourself. If I'm at negative 3, 6, so negative 3, 6, what would make that even? What would positive 3 then be? If this is negative 3, 6, what would positive 3 be? Positive 3, 6. So positive 3, 6. If I'm at negative 1, negative 4, what would positive 1 have to be at? 4 or negative 4 to be symmetric? Negative 4. If I'm at 2, negative 8, what would negative 2 have to be at? Negative 8. You can literally plot them and show that they're symmetric to the y-axis. Okay. Odd functions. I now want to think odd is symmetric to the origin, and I want to think opposite signs. All 3 O words. Odd, origin, opposite signs. So if I'm negative 3, 6, what is the opposite of negative 3, 6? 3, negative 6. So I should be positive 3, negative 6. If I'm at -1, -4, my opposite should be 1, 4. And then this one was +2, -8. I should now be -2, +8. So odd opposite signs. All right, example 3. F of x is an even function. Highlight that for yourself. That's going to give the answer away. That's your hint. So even, my brain's going symmetric to the y-axis. And I know f of 3 is 5. That is like saying I have what point? Who, comma, who? 3, 5. Input, output. What is the value of f of 3 plus 2 times f of -3? All right, so let's go. We have 4 times. What do we know about f of 3? F of 3 is based off this right here. 5, yep. Plus 2. Now I need f of -3. Now they didn't tell us f of -3, but they did tell us that we are even. So if I know f of 3 is 5, what do I know about f of -3? It's also 5 because it's symmetric to the y-axis. So this is also 5. So 5 times 4 is 20, plus 5 times 2 is 10. Okay, so you've got to pay attention to whether it's even or odd, and that will help you figure out that next point. Example 4, if f is an odd function, so now what are we thinking? Origin and opposite signs. Perfect. Origin and opposite signs. And f of 3 is 5. What is the value of f of 3 plus 2 times f of -3? Okay, so we've got 4 times. We know f of 3 is 5 plus 2 times. I need to figure out f of -3. Well, if f of 3 is 5, and I'm reflected about the origin, that means I have opposite signs. That means f of -3 is -5. So that becomes -5. So now I have 20 minus 10 should get me 10. Okay, so even, it's the same. Odd, it's the opposite. Even's the same. Odd is the opposite. All right, so graphically, fairly simple. Symmetric to the y, symmetric to the origin. Okay, so now the algebra part. So let's just review the algebraic rule on the next page here. The rule always says f of -x, if it's even, it's going to equal f of x. Box that in. And we covered these on the front. If it's odd, f of -x will equal the opposite, so will equal -f of x. Okay, so 2 rules. They're quite similar. No matter what, you're plugging in -x, and we're just comparing what we get out. If we get out the f of x function, we know we're even. If we get out the opposite of the f of x function, we're odd. And again, if you get a mix match, it's neither. So it says determine algebraically. So we got to do this by hand if it's even, odd, or neither. So I'm going to find f of -x. So I'm substituting in -x on paper. I got to show it on paper. Substitute with parentheses. Okay, so now you got to talk yourself through the cleanup. What happens when you square a negative? What should you get? Positive. So this is going to become positive x squared times 4. So that's going to be 4x squared plus 11. Okay. I then want you to take an arrow up to your original function. How would you compare those? Exact same. So if I plug in -x and I got back out f of x, which I did, that tells me this function is even. So we're going to say therefore even. And then you got to tell the greater y. F of -x equaled f of x. So you're basically just going to state the rule for them. Okay, they all work the same way. You're going to always substitute in -x and see what you get out. So let's try B. I'm going to substitute in my -x with parentheses. And then talk through what you get. -x to the 4th. So if I have a -4 times, that turns into a positive. So I have positive x to the 4th but I'm multiplying by negative 2. So that's going to be negative 2x to the fourth. If I take a negative x and I square it, I'm always going to get a positive. That's going to be positive x squared times 3. So that's a positive 3x squared. Whoops, somehow that changed to a minus. That should be a minus 1, right? Sorry. And then I have a minus 1. Okay, so again, I'm just going to draw an arrow and compare to that function up here. How would we describe it? Exact same, right? Exact same signs. Therefore, even. Because f of negative x equals f of x. When I substitute in the negative, I get out the original. All right, you try the next two and we'll compare. You're doing the same thing. You're always substituting in negative x and talking yourself through it. All right, so again, the rule is easy. We're just plugging in negative x, and we got to talk through what we get. So I have to take negative x, parenthesis exponent, to the fifth. Should that be positive or negative? Negative. 5 negatives makes a negative still. So I have negative x to the fifth times 2 would be negative 2x to the fifth. A negative 4 times a negative x would make a positive 4x. Okay, so now I want to compare that to the original. Is it the exact same? Is it the opposite? Yep. Yes, they all changed signs. Opposite means opposite signs. So we're going to say, therefore, odd, and state the rule. When I substitute in negative x, I got negative f of x. I got the opposite of f of x. All right, let's talk through D. So I substituted in negative x. So again, I've got 5 negatives, which is going to make a negative, times 3. So that's going to get me negative 3x to the fifth. A positive times a negative is a negative, and then I have a minus 1. I'm going to compare to the original. How does that compare? I've got a neither and the signs are switched. Are they opposite? So are they all opposite? No. Who did not change? The 1. So this is a case where it would be neither. Okay, so yes, this changed signs, but this did not. So either they all changed to be opposite, or it's neither. Okay, go ahead and try those last two. So same rule, f of negative x. We get the original, it's even. If we get the opposite, it's odd, and a mix is nothing. But if you're going to say even or odd, you got to state the rule with it. All right, let's look at E. 3 negatives make a negative, so I have negative x cubed plus 1. How does that compare to the original? Neither. The first one switched, but the second one did not, so I would definitely go with a neither here. On F, so I'm only substituting in here, if I square a negative, I'm always going to get a positive. So if I compare that to the original, it looks the exact same. So we're going to say therefore even, and then state your even rule. F of negative x equals f of x. When I substituted the negative in, I got out the original. Okay. All right, lastly, it's saying if f is even, what do we know about these three things? So let's highlight that word even again. The moment I hear even, I'm thinking symmetric to the y-axis. What's a nice function that's symmetric to the y-axis? Just, I think I heard it over here. X squared, like a parabola. That's kind of what I think of every time I think of even function. I picture just a parabola centered at the origin. Okay, so you're picturing an even function. So that might be a good one to start with. Make a quick little sketch for yourself. Something even, something symmetric to the y-axis. Where is graph A taking us? Up 2. If I shift this up 2, does that change my symmetry? No. So I'm going to put still even. Okay. What if I shift it down 2? Still even. Where's this guy taking us? Right 2. If I pick this graph up and move it over here, even, odd, or neither? Neither. It's definitely not symmetric to the y anymore. It's not in opposite quadrants. This is neither. This is taking me where 1? Right 1 and up 3. If I move right 1 and up 3, anything? Neither. Okay. So if it's even, it's only going to stay even if I move it vertically versus left and right. Oh, good timing. Homework is the next page. So the front's graphically, the back is algebraically. It should not take that long. What else we got? We're going to go with our normal quiz tomorrow.